Okay, I think we have enough people in here. We can go ahead and get started. So let me see. Where's the agenda? All right, the agenda's pretty short today, so we can, if anyone wants to go into a lot of detail about their stuff, feel free. The first item is going to be testing updates. Is anyone here who can speak to just updates on testing? Anything including fuzz testing or some stuff Dimitri usually does?
So Evasm team was using the same framework as the consensus tests, and they are new users of test tool, and they saw many problems regarding the user experience of the test tool, and they reported problems, and Dimitri has been fixing them.
Yoichi or whoever, I've been kind of out of the loop for a little bit, but I don't mind helping out with user experience. You guys could just put me in contact person. I can help.
Oh, thank you.
Cool.
Regarding fuzz testing and Hive testing, we've had to move all the infrastructure from Azure to AWS and getting it up again. And Guido has now joined us on the DevOps side to help run the fuzzers and maintain the new infrastructure. So we're kind of, hoping to kind of relaunch the fuzzing efforts as soon as possible.
Great. That sounds pretty cool. And Tim and Yoichi, do you all already have a contact with each other? If not, we can just share that info on Gitter.
Yeah, I think I have Yoichi's email. I'll shoot Yoichi an email.
Perfect. Cool. Any other updates for testing? Okay. So the next item is going to be fork release management, like when we're going to hard fork again in Constantinople. So the very first, I guess, subpoint, I probably should have put subpoints in here, are what EIPs will be going in. So unless someone wants to start out with a different topic, I think we should kind of discuss what EIPs should go into Metropolis, so then we can get a better idea on, or sorry, into Constantinople, so we can get a better idea of when it will happen. So I'm going to the EIP page right now. Let's start with the account abstraction, EIP 86 right now. I know, Vitalik, you had a ETH Research message post about a month ago that you said was getting some replies about it. Do you want to go over what came of that conversation?
Yeah, let me get the link to that post out. There we go. I got a lot of replies. So this was account abstraction specifically in the context of sharding, where there's less backwards compatibility requirements. But like basically the main proposal that people so far seem to like the most is involved basically in the pay gas opcode. So the idea here is that there would be a new opcode called pay gas, which would have two functions. One of them is paying actually paying for gas, and it would have like built-in functionality to refund any unused gas at the end. And the second functionality that it has is that if a transaction throws before the pay gas opcode has been called at any point, then the transaction is totally invalid. But if the top level or if transaction execution throws after the pay gas opcode has been called, then the transaction is valid. And the purpose of this is basically that kind of any execution before the pay gas opcode is like execution that should be considered as kind of part of basic verification. So it will include things like signatures, it will include nonces. In some cases, it might include more things. And anything that comes after the pay gas opcode is kind of part of the full execution. And the way that miners would generally work is that every miner would privately choose some threshold of gas, like possibly 100,000 gas, could be something else. And anytime they receive a transaction, they would run the transaction execution for up to that amount of gas. And if the pay gas opcode has been called, then they know that the transaction will pay for itself, and they'll run it fully and they'll include it. But if it has not, then they'll abandon the transaction. And so this basically kind of substitutes the distinction between like pre-verification and full transaction execution. But there was another part of the discussion which had to do with nonces or in-protocol nonces versus not in-protocol, not having in-protocol nonces. In the context of the sharding discussion, it's leaning toward not doing that. But in the context of outside the sharding discussion, that would have like much higher transition costs because it would involve moving to transactions potentially appearing more than one time in the blockchain. And so like in the context of the main blockchain, it might make sense to like do the pay gas proposal, but then have have a separate in-protocol non-verification mechanism.
So a question about that, Vitalik. With the pay gas proposition, it's not possible to pay for gas with ERC20 tokens and stuff like that, right?
Correct, it's not.
And so what concrete abstraction benefits are there?
Okay. So number one, signature abstraction. So you can use whatever signature scheme you want. Number two, like replay protection abstraction. So like nonces, UTXOs. Like one particular example is if you have something like, let's say, like a ring signature mixer contract, then like a ring signature mixer contract it already has its own replay protection because the linkable ring signature mechanism itself prevents you from using the same key to withdraw multiple times. But if you try to force that kind of contract to have nonces, then like you're going to have a problem because you're basically if two people send a transaction around the same time, then if one gets in, the other will have to update their transaction. It also lets you do other stuff, like it lets you potentially make pre-verifications much more complex. So one motivating use case that I was thinking about was like ICOs, where if you have an ICO where, let's say there's 100,000 people that want to participate, but there's a cap, and so after the first 20,000, no one else can join, then like the status quo is basically that all 100,000 transactions would go in, but the last 80,000 would just basically turn into no ops. Whereas with this scheme, if the 100,000 and if the verification in the ICO contracts could be made to be compact enough, which it probably could be given that like checking a number against the threshold isn't more complicated than a signature, then you could actually have a scheme where the 80,000 transactions that don't make it into the ICO in time actually don't have to pay for the fee and don't take up gas space. But yeah, you're right. It does not. This does not let you pay for gas with ERC20s.
By the way,
Although,
86 still relevant? So
What was
if
that?
86 is considered for Constantinople, and is it still relevant? So the if page readme lists the ifs deferred for Constantinople, and if 86 is not considered anymore, that should be replaced with something else.
And if people want me to make an if for this abstraction proposal, I can totally make one.
Yeah, you probably should if you want it to go into Constantinople. Okay. I'm not. Does this need to? I guess the question is, does this go into Constantinople?
Yeah, I mean, so one like So one question for developers is like basically how much development effort would this take, and would this kind of possibly detract from other things?
Yeah, so I've seen you wrote about this proposal at research, right?
Yeah, I put the link in the Skype. Hold on.
I don't know if all developers read this. I happened to read it last week to refresh my memory, but you might want to post it again so people can read about it.
Cool.
So probably the answer to my question would be the CP86 might be replaced with something else, because I mean, at most one of those proposals in its research would be identical to 86, so might become something else.
Yeah, so I would say at this point, like personally, I'm not super interested in the IP86, but
I see.
Yeah, I think we mentioned that on some earlier Core call, and I can't remember which, but I think it was kind of generally said that the EP86 is would probably not be included, and that Vitalik instead would write some other proposal or proposals which are presented on at research.
So maybe we can kind of downgrade 86 into.
Okay, I see it.
Right.
Wow, I actually did not see EIP60, did not even see EIP61 at all before, but I guess the main difference between that and this proposal is that this proposal also has the mechanism where if a transaction exits before pay gas, then it's invalid if it executes after it's valid in the coupling with account abstraction. So it kind of does more things.
So hold on. So it's actually invalid. It's not just doesn't pay for itself.
Yeah. So if, like in my proposal, if a transaction exits execution before a pay gas opcode has been called, and like it could even be called like pay gas with an argument of 0 if you don't want to actually pay, then like if it gets executed before that happens, and the transaction fails, then it's like that transaction is actually not allowed to be included in the block.
Hi, it's Alexei here. So I would also, Vitalik, I would also add another restriction because I could see like this could be used as the attack vector. So I would add the restriction that before the paygas instruction is called, you're not allowed to access the state, only the local information from the transaction.
That's a bad idea. Basically, because like there are like a lot of the motivating cases that I think about actually require you to access the state before in order to do like various checks. So one example would be checking the nonce. Another example is this ICO example. Another example is the rakeable signature case. Like all the interesting ones require you to access the state before pay gas.
Okay. Well. Okay.
Yeah. Like basically, if a miner is concerned about dot vectors, then it would the simplest response would be to just decrease the amount of gas that it's willing to execute.
Yeah, it will become a bit more complex for nodes to validate that the transaction is valid.
No, I agree with that. Like,
yeah. So I would suggest that if we have make it into an ETH and have the continued discussion on that ETH.
Mm-hmm.
Yeah, I agree. I don't think, I mean, unless any client devs want to give any kind of estimate as to the amount of work required for this, I don't know if we can today without an ETH. But if anyone has any other comments on that, feel free.
Mm-hmm.
And just so that I make sure I understand, is this the type of ETH that would allow contracts to pay for themselves?
Yeah.
Okay,
I mean, that's one of the things that it can do.
perfect. Okay, so any other comments on specifically that one? It looks like we're retiring 86 or removing it at least from deferred, and then Vitalik's going to write a new EAP outlining the new pay gas plan potentially. Great. Any other comments?
Maybe it's a good moment to clear up this deferred EAP table. So if nobody has a comment on 86, we can move on to, there are two more, like 96 is the block hash contract thing. And the third one is the bitwise shifting. And yeah, I want to ask if, the EAP authors are still pushing this or actually thinking about something better.
Yeah, so the first one is EIP 96 block hash refactoring from Vitalik, and that is on deferred. That was going to be, we were thinking that would be in Constantinople. Does anyone have an opinion on that, or Vitalik? Is that something you still want to push for Constantinople?
Don't have too strong an opinion either way.
Anyone want to speak on the benefits of that, or?
I mean, I personally think that at this point it's lower value than either Casper or abstraction or just like devs spending more time researching ways to make their client implementations 5% faster.
Anybody else have a different opinion?
Yeah, actually, I would like to see it being shipped because it's more aligned with removing some interesting features for EVM to external contracts, like some kind of precompiled contracts, or that like removing features from internal EVM to be available in address on a smart contract, which will like make future upgrades easier than shipping that all the time.
So now that I think about it, I might have changed my opinion. The reason why is that I think it might be good practice for the much bigger round of kind of EVM code being a base protocol feature that we're going to introduce later, which is the Casper contract.
Yeah, that's what, like good like small example to test this approach. Yeah, I agree with that.
We would like to include it in the EWASM testnet.
I have a comment on the EIP 61 that you were talking about, the contracts paying for their own gas. Wouldn't it be simpler and not require as much changes to how we expect things to work instead of the contract paying their own gas? It's just add a secondary payer to the contract where the person who signs the transaction is not necessarily the one who's paying for it, but there's someone signing the transaction, and someone else can just post that transaction on the blockchain, and that person will pay the gas. That allows more flexibility, where I can sign a transaction and send it to someone else, and that person pays the gas for the transaction, but under my name. I think it might change less things on the VM and on how we expect contracts to work. And it also is similar to how a lot of contracts are doing, where they just sign a message and send somewhere off chain. I can try to just write that down and start a discussion on IP. Maybe this is not the place for it.
Yeah, and you said that was EIP 61, right? Or 86? Oh, Alex, did you say that was for EIP 61?
Oh yeah, the 61 is the older one. You're talking about the 186, right? Yeah.
Oh, got it, 186. Okay. Cool. Yeah, and after you, when you do that comment, just put the comment in all core devs, and I think that would be good. Let's see. So that kind of went over 96 a little bit. Vitalik, you said you changed your opinion to where it's a little bit more important, and the EWASM team kind of feels the same way. it sounds like. Okay. So, is there any comment on the level of difficulty for implementing that, or is that, and also, I guess the better question, is that EIP fleshed out at this point, or is there some unanswered questions within the EIP for design and implementation questions?
Difficulty is not that high. I saw requests for CPPSLM gates, and it's not big. It's kind of on a particular block you have to deploy some code, and after that you have to run that on every block. Yeah, I mean, not that big. And then the second question was what?
Oh, yeah. So you just answered the question of the amount of difficulty. Mine was this pull.
Yes, design issues remaining or not. So the main thing is, I guess it was Pablo preparing somewhat a little bit more efficient version. He was preparing a little bit more efficient version, and if that's worth it or not. I mean, so it's purely about this EVM bytecode that would be deployed, and there is a little bit room of more efficient storage usage, but it's very little bit. So when we were planning this for an immediate fork, Vitalik once judged this tiny improvement, tiny optimization is not worth it. But this time, I mean, if Constantinople is not that urgently coming, this optimization can be considered again, I think.
Okay. And that's, you said, from based on Pavel's comments?
Based on, well, I had some conversations with him, and yes, I saw his comments.
Okay.
So I think there was like on the way there was like 3 versions of the contract. Like one was from Vitalik originally, then I did some proposed some changes there, and then was another one that was a bit more generalized and includes everything in some kind of tight loop. So I don't remember exactly, but I think we just have to review that code again at some point. And yeah, but it's just one note is from me is that like that centralized effort to have this bytecode ready, so it doesn't like it's not included in the developer's time for actually implement that in clients.
Okay, that makes sense. So you're saying it would save developer time if we collaborate to create the bytecode?
It's a part of specification, so like whatever code we will agree on, in the end, it doesn't like affect the client's time spent on implementing that.
Okay, understood. Yeah, I think that's good. Okay, and then lastly on this, I mean, there might be other comments, but specifically from me, this EIP, which one? Oh, EIP 96, Piper, I saw that there was a merge in the last month where you refactored the VM state and blocked a new apply transaction. Did you actually, and it referenced this EIP, did you actually already partially implement this EIP?
So this is going to be me code reviewing. One of the other devs working on sharding is going to be the one who actually did that work. I'm scrambling real quick to pull up what you're referencing.
I'll paste it in.
Thank you. Yeah, so we are quickly working towards having a pure apply transaction concept in PyEVM, essentially getting ready for stateless clients, and getting ready for being able to run it under that paradigm. So that is moving along quickly, and we've got a lot of that into the core library now. We're kind of backporting these things from the sharding branch into kind of our main branch as they seem appropriate.
Okay, thanks. That answered my question. Perfect. Any other comments on 96 or 86? And because we'll move on to 145 after. Yeah, my understanding on 96 is there needs to be more collaboration. So if some of the people who discussed this, Vitalik, Pavel, Yoichi, others who've been involved in the conversation for EIP 96, if y'all could start rehashing that a little bit and getting a more formal EIP, that'll help us the next core dev meeting. Okay, EIP 145, bitwise shifting instructions in the EVM. That was Alex Berzazzi and Pavel. So if one of you guys could kind of comment on this, kind of just bring up what it is again, and if it should go into Constantinople. Oh, whoever's explaining it might be muted.
Yeah, so the AP it's ready and has been merged, so it can get another round of peer reviews, and we also have the CPP implementation ready. Except we need some way of configure the client to actually include this feature in the VM. So it can either go with some kind of fake Constantinople fork, or can be some separate configuration that enables only this one. That's the only thing that hasn't been done yet, and we can start after that. We can start making tests and so on. So.
Okay, so it sounds like you need one more client implementation. Would that be correct to say you need one more client implementation to have like a little mini testnet you can run with just this change?
I'm not sure it deserves a testnet, but we at least can have a classic JSON test for this case. And yeah, so some alternative implementation would be welcome. If not, some of us can actually jump on and implement that, and in Go probably. So shouldn't be like big deal, considering it's using only some additional functions from big number libraries.
Okay, Alex, did you have any comments?
There is also support in Solidity for it.
Okay, nice. Yep, I see that. It's listed under implementation in the EIP. Great.
And it would be fairly easy to support it in the JavaScript VM. If the number of client implementations is the limiting factor.
Okay, sounds good. Usually, at least for EIPs getting accepted, there needs to be a few implementations, but if it's on its way, like there's implementations in progress, that can be considered as well. Is kind of how we've been doing it as far as I understand. Okay, so any other comments on 145?
Yes. Could we please have the test cases expanded? Because it's really annoying when you have an EIP that, even though it's kind of trivial, if you don't have any test cases, it's just like shooting in the dark and hoping that it kind of works okay.
I don't think we have a proper rule yet on the test cases. Because with some of the Byzantium EAPs, some people started to put a couple of test cases in the EAPs itself, but then all the other useful test cases were written up with test ETH, and none of those were ported back to the EAPs. So I'm not sure where test cases should be located.
I'm not saying that the test cases should cover all the corner cases or should be too exhaustive, but it would really help if there would be at least a handful of 2, 3, however many test cases that just kind of cover some generic use cases, so that I, as an implementer, if I implement my code, I can actually check it that it kind of seems to work before even getting to the point of picking it up and merging into master. It's just kind of a nice feedback for implementations.
Yeah, I understand. Yeah, we'll done it. We'll do it. Okay.
I think that's the level we had in the revert EAP. It only had like 1 or 2 test cases, just a successful one, and everything else was tested by the big test suite. If that's acceptable.
I mean, for this case, I think we can have up to 20. It shouldn't be like big deal to also cover some negative cases. I mean, it's I think it's general practice to, for example, having some hash functions example tests included in spec usually. So I think that in this case that should be fine to have them as a part of specification.
I agree.
Yeah, does the Ethereum test repo doesn't have any, or this one does it, since it's like a new opcode or whatever, or does it already have the shifting test?
Could you repeat the last part of that question, Tim? It was hard to hear.
Yeah, sorry about that. I was wondering if there were test case in the Ethereum test repository. I had assumed there were not, given that it's a new opcode bit shifting or whatever.
I think there are no tests for this one in the test repository. The main blocker is actually there's only option to actually include them in some kind of new fork configuration or new network name and so on. So like there is no way to actually have some separate branch.
Okay.
So
I
we can
understand.
include them in Constantinople if
Right.
considering that will ship with that, but I think there is no good way of enabling individual features separately.
Okay, cool.
Unless we figure out how to actually upgrade the test to be able to do it this way.
I don't think I know enough, but I'll think about that.
Yeah, it sounds like there aren't any in there right now, but there definitely could be in the future.
I think the way it works, if you agree on like a fork name tentatively, like Constantinople, then we could merge it in the CDP client and test it. Could generate the test cases under the Constantinople fork name for the bitwise shifting, but it needs to have a name in order to generate the tests.
Yeah, I think that's why we are talking about it here, so that we can have a reasonable expectation what Constantinople would be, and then we can start doing that.
So this EIP seems like a fairly trivial one. So if we consider adding it, then we can consider adding it to the first upcoming hard fork. So unless anyone is actually opposing adding the opcodes, I think it's fine to add it to Constantinople.
Yeah, I've never heard anyone opposed, so I'd say it's going in. Cool. Any other comments on 145? I guess the next steps are to work on some test cases for that and have people review the EIP again now that it's been edited a few times, potentially since people last saw it. Is that accurate, or has it been pretty final for a while, Alex or Pavel?
I think it's been final for 2 years at this point. There was one single change like 6 months ago. The operands were swapped, and we discussed it probably 5 core dev meetings ago, but no changes since.
Oh, sounds like it's good to go then. Cool. In that case, yeah, we'll just say it's going into Constantinople unless someone between now and the next core dev meeting has any opposition. Sounds good. And we know what we're working on there. So that's it for the deferred EIPs table. So it looks like from that conversation, we have 86 going to be replaced by something that Vitalik will come up with involving pay gas and potentially some other things. 96. What did we decide on with 96? I forgot.
That we're going to look into doing it.
Yep, that's what it was. We're gonna, yeah, basically look at the EIP and add some more detail, and then 145, that's gonna go in. Cool. Are there other EIPs that are not in the deferred table that people are interested in including in Constantinople that they have handy? If they don't, we'll talk about this next meeting, but yeah.
Probably the ones that have to do with account cleanup. So I think it was 169 and 170.
Okay. And I think something that we should do between now and next meeting is just talk in the core dev meeting about the list of the state clearing ones and which ones should go in. And can you remind me again, just in a nutshell, what 169, 170, I think is the ones you just said, what they do?
Yeah. So one of them is that if an account's balance drops below like 21,000 times that transaction's gas price, then the account disappears. And the other one says that if, like, when you create a new account, the initial nonce has to be instead of being 0, it's some different number, and like that basically just does replay protection in the context of accounts being able to disappear sometimes.
Replay. Oh, okay. So when you say some other number, like a random number?
No, it's like some globally incrementing counter.
Oh, okay.
Could be like the block number or something, right?
Yeah, it's something. Well, no, it's either the block number or it's just like a global counter that's like the maximum of all nonsense that there's ever been.
Okay. Yeah, between now and next meeting, let's get those together and we can discuss them more next meeting after some people have had a chance to read them, unless anyone else has comments on those right now. Are there any other EIPs that should be considered for Constantinople that people have thought about for today? And then additionally, do we want to start doing somewhat of a timeline or kind of even just like a rough Q1, Q2, Q3, or Q4 for Constantinople? Guessing not Q1, because we're in the middle of that right now. But is this something that could probably be done by, Q3 maybe? Anybody have an estimate, or do we need to kind of flesh out the rest of the EIPs before deciding that?
Probably flush out the EIPs.
Yeah, that sounds good. We can do that more so by next meeting. I still like the idea of timing it so where we have like a month to decide on EIPs, multiple months to implement, multiple months to test, and then release, and coming up with some hard timelines on those goals and those milestones. So we should hopefully by next meeting come up with some more EIPs, and I think that that will help us start formulating how much time we have left. Okay. Any other comments on Constantinople, EIPs, that stuff? Okay. I want to go back to testing real quick because Dimitri is able to join us. So, Dimitri, I know you left a comment on the agenda about test optimization. Do you want to go over that a little bit or describe it?
Hi, yeah, hello.
Hello, we can hear you.
Okay. So I was working on this test ETH optimization. I saw that we have many tests that we just run because of our previous optimization, that every test case is being executed on every fork. But now we have another fork and another fork, and we have like hundreds of tests being executed, and most of them are just wasting our time because, for example, static call tests are being executed on all forks, but we don't need to run static call tests on Frontier, Homestead, and other hard forks which do not introduce this opcode. So I want to remove those tests, and it will actually change the test format. Well, clients might not need to implement any changes actually, because it will just remove some post states from the tests, and that's it. It's mostly for the test fillers. So now I plan to create a test from the test filler for only those networks that are specified. Only those networks means forks. Networks and forks that specified an expect section of the test filler. So when you create a test, you could specify on which forks this test will be executed.
Dimitri, this is Piper. One thing that is good that we should try to make sure that we maintain is that the tests are still verifying that like the static call opcode doesn't work in Frontier, because I know that that was an error at some point.
This is another test case. We could just we already have a test which execute all of the opcodes on all of the forks. That was done by Jared. Yeah, and it basically checks that every opcode. It tries to execute every opcode on every fork and see what are the results.
Great. I just wanted to make sure that that protection stayed.
Yes. But this is only one test case. We don't need to execute every possible situation with a static call on Frontier. We could just try to run it, and if see that it doesn't work, and this is one test case.
Slimming down the JSON test suite sounds wonderful. We have like an hour and a half long CI run or something like that for largely due to those. So.
Well, also we have a YAML support now implemented, so you could develop test fillers in YAML format.
That's great news. Awesome. Any other testing updates from anybody?
I think EVS WASM upgrade is in research. Like Axic is working on WASM source code integration into test fillers, and test it could already compile some of the code, but it's not being passed by EVM just yet.
Okay. Let me see something real quick. There's just a comment I'm checking on. Yep. So, yeah, that is the correct decision. Axic had me look at the comment on the agenda about the EIP 145 decision, and yeah, that is exactly what we came up with. Need to include a couple of test cases and start having clients implement if that works. Let me see, what's the next item on the agenda? Oh, so someone on the agenda asked if we'll see short-term scaling improvements with Geth 1.8 by increasing the gas limits without having the uncle rate go massively up. I don't know if they understand the correlation between gas limits, uncle rate, and the client updates. But we'll probably just go into client updates right now so that we can get all the updates from Geth, including their 1.8 release. So let's see. Geth 1.8. So Peter, yeah, if you want to go first with Geth.
Yeah, sure. So I think the question kind of was referring to whether block processing will speed up enough so that we don't see a lot of uncles out there. So I think it's kind of important to know exactly what we aim to ship in 1.80. And so one of the problems currently with Geth is that once you sync, you do a fast sync, which consumes whatever amount of disk space the current Ethereum state consumes. But afterwards, Geth kind of acts as a full node, which means that your state, you kind of act as an archive node from that point onward. And then the state kind of just bloats on your machine, and eventually your machine slows down. And what we are actually working on currently is to do an in-memory state pruning so that we try to actually keep as much of the junk in memory only and clean it out in memory and only flush the disk periodically, or if we're actually reaching critical memory usage or something. And basically, we haven't done any too scientific measurements yet. So we started on importing the entire full chain. It kind of shows it is promising. We also started some benchmarks, really preliminary benchmarks on the mainnet. And as far as I can see, it reduces disk growth by about 80%. So that's kind of really nice. But to answer the specific question posted on GitHub, whether this will help anchor rate or not. So this will not speed Go Ethereum up, but it will actually prevent it from slowing down, or at least slowing down too fast. So this is, in my opinion, it will be a very welcome change, because then you don't need to resync so often, maybe just 5 times, or sorry, 1/5 of the time. And we also have a separate pull request or proof of concept experimentation to actually implement full garbage collection too, so that so currently what we do is that we try to minimize the amount of junk we write to disk, but we still occasionally have to write to disk to flush out from memory. And in a follow-up work, that's probably going to be 1.90. I really hope that we can actually get full garbage collection implemented so that even past junk that we had to write out to disk can be cleaned up afterwards. So that definitely won't come for the next release, but I would really like to have the next release a much more stable one and much more usable one than the previous ones. So that's mostly the scalability fixes that we're working on. Otherwise, there's a ton of work going in on various fronts, like client, networking, etc. But you probably want to check out. I don't think this is the appropriate channel for that.
Yeah, we'll just wait till the full release and we can go over all of the updates once that's happened. But that's a good update, and glad things are working out there. Next, we're going to have Parity. Afri?
Yes. Do you hear me?
Yep.
We just released 1.9 today. It turned out to be one of our fastest clients so far. I have to admit we didn't expect that, so we had a lot of trouble with broken warp sync and database issues, but they seem to be fixed, or some issues seem to be resolved. So we are pretty satisfied with the current release. And yeah, so for the future, warp sync or snapshot sync will be hard to maintain on the Ethereum network due to the growing state size. And we are currently at the point where it takes longer for a client to generate a new snapshot than new blocks are mined in this window between 2 snapshots. So the result is that there are not enough snapshots or not enough nodes serving snapshots on the network. And our focus for the next weeks and months is to put more effort into light client development to ease end user experience. Yeah, and another thing we are doing is reducing our user interface. We want to reduce functionality and split out the parity wallet at all. We already disabled multi-signature wallets, and yeah, we just want to refocus more on core technologies. Yeah. And the last point on my list is that we also want to start implementing Casper support, Casper testnet support within the next weeks. So that's parity updates.
Great. And a question: Are you still, or is Parity still planning on doing their own custom database format? I think it was like Parity DB.
Oh yeah.
Oh, Afri, I think you cut out. Can you hear us? Oh, I think we might have lost him.
I don't hear him either.
Okay. We'll go to the next client for now. The next client, let's go ahead and do Harmony. Mikkel?
Yeah, hi. We have implemented our first version of Casper Aware node. So the node is able to sync with other clients in the hybrid consensus network.
By other clients, do you mean the Ethereum one? Or
yeah, I mean that already the clients that already have a Casper implementation, but we tried to test it in a Casper test network. We used the directions from Alpha Casper testnet instructions post made by Carl, but looks like that boot nodes are not working or something like that. So the question is, who is the best contact, or what is the best channel to ask about the problems with the Casper?
Reach out to myself, and I will both help and put you in touch with the other people.
Yeah, okay, great. Thanks, Vitalik. Yeah, we definitely will try to test it offline with the Dockers, which are also mentioned in that post. But it would be nice to test it in the live network also. Yeah, that's our update. All updates, I think.
Okay, thank you very much. Next we have, let's see. Let's go with CPP Ethereum.
So we have EWASM VM integrated, so it can run EWASM as a VM for smart contracts. That's, I think, the only thing I would like to share in terms of CPP node. I also released ifminer if anyone is interested. Its version 0.13. And thanks for all external contributors that make it happen. We have a very nice community there.
Great. Ethereum JS.
No major updates on Ethereum JS, just keeping up with the maintenance pretty well.
Great. PyVM.
Cool. So we are rebranding as sorts. So we're calling our client Trinity. And so that's what we'll be referring to the actual Python client as.
Sweet.
Going forward. We got started on the command line interface, like the formal implementation of that, and are working as fast as we can towards, I mean, we're in an alpha release stage right now, but the alphas are not really usable as a client, and we're working as quickly as we can towards an alpha release that includes a kind of runnable node using that command line interface. Lots of work still going on with sharding and things getting merged there. Like I said earlier, we've got some stuff going in for being able to support running a stateless client, that sort of thing. And just lots of under the hood work going on to get towards something that can be released as an early alpha.
Okay, good update. Thank you. Alexi with TurboGeth or any of the other optimizations you've been working on?
Yes, hello. So I'm still working pretty much full time on this TurboGeth thing, which is just at the moment it's just an experiment, but I'm just doing my last kind of optimization, and after that I will try to stabilize it and just run through all the tests. So the updates I have been able to make the sync much faster, and I have also noticed that the memory size does matter. Like I was trying to run through the spam blocks, for example, sync with unconstrained memory, like to keep everything, all the state tree in the memory. And it did actually go through that much faster than if you don't give it unlimited memory. And it consumed about 676 gigabytes, I think, of memory to get through that. And then, of course, after the state clearing, the state compresses again. Unfortunately, I didn't get to run it very far because I still need to implement reorgs, and so. But that's what I'm working at the moment. Yeah. So my plan is to just try to stabilize it and see if it could be actually made work as a client. That's it.
Mhm.
Okay, great. Let's see. Lastly, for the list of client and research updates, let's just go to research. So Vitalik, if you want to give kind of a overview of research updates, specifically Casper and sharding, I guess, just so we're kind of up to date.
Sure. So on the Casper side, the alpha Casper FFG testnet has been running for a few weeks, and I'll paste the each stats for that. It has not been running too well, mainly because we realized that like Ethereum networking is actually not good enough to like it's okay for connecting to a network, but it's not good enough for maintaining a network all by itself without other nodes. And so it's ended up requiring quite a bit of active maintenance and some firewalls and a couple other hacks to get around the fact that we're getting like 200 random GEF and parity connections coming into each node. Though that said, the Casper aspect of Casper, where it's where if a block is final, like basically two conflicting blocks should not be possible to get finalized, seems to actually have been running, and the network seems to actually kind of have agreed all along as to what the finalized chain is. So that part has been totally successful. So far, that's kind of on the back on a bit of a back burner while we wait. So we're trying to simultaneously optimize that, and we're ready to kind of help other clients along in joining the Casper testnet. Also on the sharding side, quite a lot of work has started, and so there's quite a bit in the repo. It's here. I'll paste the repo here, where we're basically doing the sharding implementation on top of PyEVM. There's a basic spec that is over here at this link over here, which has been updated a lot, and it's theoretically, I think, good enough as a kind of full spec of what kind of minimal stage 1 sharding is going to look like. And it's about And there's like Shellway, I think, has something like a 4-phase roadmap for getting it actually deployed. And it seems like kind of part 1 of phase 1 is getting this something like being already done, and we expect like the next stage to be finished after a month and a bit. So the main we've been working a lot on getting some of the auxiliary changes. So things like account access list, account abstraction, written into PyEVM, and we've spent a lot of time on developing a new binary tree, developing like witness compression for the binary tree. The next step will probably be actually getting the stateless client logic with like syncing blocks and witnesses working well, and then from there we're going to kind of try to turn it into a working kind of test network in parallel with PyEVM getting full node functionality working.
Great. That sounds good. Let's see. Do we have anything else on the agenda? I don't think we do. Did I miss any clients or any other major updates for people doing research? Oh, I guess Yellow Paper recently, there has been a lot of changes to the Yellow Paper, Yoichi, if you wanted to go over that.
So thanks to Gavin's license, Nick Savos was able to merge my pull request about the Byzantium changes into Yellow Paper master. And there are enthusiastic contributors who are fixing typos or adding internal hyperlinks in the document. So yes, they have started adding hyperlinks so that when you click on an unknown symbol, you can jump to the definition of that thing.
That sounds really cool.
Getting better and better.
Awesome. Any other client or research updates?
It's not a client update, but we are approaching a stable v4 of Web3 PY, which we've got some really nice new stuff in there. Jason Carver, the lead dev on that, wrote a nice blog post covering a number of those, but some of them are gas price APIs that mirror some of the functionality of the ETH gas station, which I think a lot of clients are either adopting, and if they aren't, they should look into adopting something along those lines, because it is a solid algorithm for doing gas price projections.
Cool. Yeah, I saw that blog post, and I'll link that in the meeting notes after. Anybody else have any other updates on clients or research? Does anyone have any other items that they want to bring up outside of the agenda items? Any other final comments? Otherwise, we're pretty much done. Okay. Well, thanks everybody, and we will talk to you in 2 weeks. Goodbye.
Bye-bye.
Bye-bye, everybody.
Cheers.
See you guys.
Bye-bye.